All right, good morning all. Welcome to spring quarter um, at the Enzo College. I'm the host for this course, Intro to SQL CIS 64B at the Enzo College. We'll go ahead and get started. Um, as I indicated earlier, live lectures are recorded and videos are posted 24 hours after the recording. Your lectures are held every Tuesday from 9 to 10:30. I encourage all of you to attend. In case you're not able to, I encourage you all to watch the recording. If during the live session, if you have a question, please put that in the chat room and I'll be glad to answer it in time during the live lectures. I do take some or I type some running notes during the lecture which I'll post in the discussion board. I do have a class website for you all and I'll post that link for your reference right here. So class website is right here and as long as you remember this URL apjava.sukhjit.tv, you guys should be able to access the class content, assignments, and videos. You will be given access to the class discussion board and I'll enable that by Friday this week using a website called piazza.com. This is by invitation to all registered students in class. I'm going to wait for the class list to settle because first week people are shopping, so at the end of the week when the class list is settled, I will invite everybody and you guys then can participate in the online discussions to ask technical questions. All your labs are submitted by email and that email address is cislabs05@gmail.com and you can find this information in the syllabus, and as I go through today's agenda I will mention information about lab submissions as well, so that should also be very clear. Now that we got this basic info out of the way, what I plan to cover in today's session is tell you about the course. So these will be some of the information. I'll be covering some of the information about what the course is all about, what will be covered, how you'll be graded, how to submit assignments, how to participate in discussion board, all the different accounts that are needed for accessing, for succeeding in this course. And I'll probably talk a little bit about myself, and then we'll get into the first topic, which is Introduction to Databases, to prepare you for the first assignment. A lot of you may be new to online courses, so succeeding in an online course can be a different experience than a classroom experience. For example, if you're in a live lecture in a physical classroom, you can see everybody. Here, you can basically hear me. You can see what I'm typing, and the sense of community that is there in the on-ground classes, created through this online medium. So one thing that I do want to provide you all with is some tips on how to succeed in this course. So one is participate in live lectures if you can. Attend live lectures if possible. The other tip I can provide is participate in discussion board. You'll get to know, you can post questions anonymously, and that way you can still get the technical answers you choose. When participating in discussion board, focus on technical questions and get those answered. Focus on delivery of assignments. Please look, I'm going to go through what assignments are, what the due dates are. So just focus on the delivery of each assignment. This course is very structured and mechanical in the sense that you will learn a concept and apply. And focus on the delivery of assignments each week and on time. Prepare to learn what you need to know for the assignment. So plan a little ahead. And if you fall behind, reach out. Reach out by email or by phone. My phone number is in the syllabus. It's 408-864-5566. So you can reach out to me, and I'll be glad to provide you. With information on with any assistance that you all may need. And then, of course, submitting assignments on time. Follow the instructions, and if you have a question about the instructions for following assignments, then definitely reach out. Set up a time one-on-one if you need to, and I'll be glad to help. And last but not least, don't give up. I mean, point is that it will take persistence and get the answers that you need, and then succeed. Now, what happens in this course? Well, like what content-wise, what's covered? So this is obviously laid out in the syllabus in detail, but I just want to give you my perspective. Content-wise, we talk about introduction to databases, and we talk about both relational and non-relational databases to start off. But we are going to cover, because the course is structured query language, we're going to first focus on, we're only going to focus mostly on relational databases because that's where SQL is used. So knowing what a relational database is and how to access data and how to store data in it is part of essentially this course. So we're going to cover structured query language, SQL. Essentially a usage of the relational database. So I start with the basics of DML operations. DML stands for Data Manipulation Language. Which means we will look at how to insert, update, and delete data at a high level. We also, you'll also learn the database architecture. So there are all these bells and whistles in the database that work together for providing the outcome of the database. So the database architecture is covered also. Then we spend about 3.5 weeks, 3.5 weeks on select statement. This is how to access data. So you're going to learn a few things here. How to access data from one table, multiple tables, and then we are going to talk about using functions in the database with different data types. We're also going to look at working with groups of data, writing subqueries, and working with views. You're going to find a total of about 5 lab assignments in this area. This area is very important. This is, once you master the select statement, you are going to be in a position, to in fact deal with being a data analyst. You can basically be a data analyst using SQL with relational systems. Once I've gone through the select statement, then it's time to understand how to create relational structures. So we cover database relationships and the process for creating a relational database. Once we have covered this, then I give you one lab in this area. So you're going to create a database structure, or what we also refer to that as a DB schema. And you're going to present that in a graphical format in the lab assignment. So the second last portion of the course is working on creating the tables and indexes. So there's one lab on this. So you'll actually be able to create a database with your with tables and indexes you set up using the graphical structure, using the schema created in lab 6. So this is labs 1 through 5. This is lab 6, and when you're working on creating tables in this lab, that is lab 7. And then the last lab is applying DML statements and improving the database schema, which is basically one lab, and that's lab 8, built using lab 7. So I'm also going to cover a little bit on database utilities. So you can learn how to import and export data, how to load data in database, and database security. Because you have to give you have to give targeted access or focused access to users. So we learn how to create users, set up database privileges, so the right user can see the right data at a given point in time. So this is what is covered in the entire course. You guys will have a midterm, a final, and 8 lab assignments. And the dates for these assignments are spelled out in the syllabus. As you can see, I do keep office hours from 1 to 2:50, and you can reach me on this number for during my office hours. You can also set up a time in case you need assistance for specific questions. There's a textbook that's required, and you can get the second or third edition as you see fit. There's also a sequel in a nutshell. I treat both of these books as references. So because SQL is such a deep topic that we cover the important 5% of SQL in this course to get you started with the language. But then there is a lot of other information that you can capture using these books. As problems come up, you can use the textbooks as reference. I do expect all of you will submit your own work. So there's a little bit of information on academic dishonesty. Please do consider reviewing this. I basically, in a nutshell, I don't tolerate cheating. So please stay away from that. Submitting assignments, I have instructions here. So basically, as we go through, I do expect that you would put this information in the text file or the email that is submitted to CIS Labs 05. When you are submitting your Lab 1, you can type everything in a text file and send it to me because there is no coding that you are doing. Eventually, we will get to creating a SQL file and a text file. And when we talk about Lab 2 submission, I will cover this in more detail so you're clear about how I expect you all to work with the code and do a test run and submit the output. I have a due dates calendar, and actually let's jump to that very quickly so we can look at that, and your due dates are all published here essentially. I think there's a question regarding the midterm. Midterm is on a Tuesday, so that should be May 23rd. And I think it says May 21st. That's a mistake, and I will go ahead and correct that because that's misleading. So that should be May 23rd, and the final is also on a Tuesday, which should fall on June 27th. We'll confirm that too. So yeah, your midterm and final are on these two are on these two dates. So let me go ahead and save that file so you guys can see the newer copy. I will urge all of you to plan to take the exam on one of these times, either in the morning or in the evening. So basically what that means is I'm going to end up writing 2 midterms, one for the morning and one for the evening. They'll be quite different, and you can, a lot of you during this quarter mentioned you may not be able to attend because you're working during the day, and that's totally acceptable. It's an online class, so you can work at your own pace. I do have to host the live lectures during the time we are at right now, but the fact that I provide the recording can work effectively for others that are not able to attend the live lecture. I do ask that you take the exam during one of these time slots on May 23rd for the midterm and June 27th for the final. Let's see. There are some questions in this in the chat room, so let me address those. The exam date is addressed on May 23rd and June 27th. you for the textbook, if you have the SQL for mere models, that will suffice. You don't need the second one. And the notes that I'm typing, I'm going to post those in the discussion board on Piazza. And so you'll get access to those by Friday. For today, what I'll do is take this text file and email it to all of you folks. Okay. Does this course teach about SQL injection? No, it does not. This course covers the topics that I covered. Okay, so it looks like all the questions are addressed. And in case you do have any more questions, please let me know. I will continue. So submitting lab assignments, I talked briefly about. Like what you can do for assignment 1 is answer these questions in a text file and send the text file along with the requested information in the header. Let me bring that up. This is the lab assignment information in the header, and you can then submit it to CIS Labs 05. In the subject of the email, I ask that you put either CIS 64B or Intro to SQL, so I know that the lab assignment is from the SQL class, because I get assignments for all classes in that one email. I do expect assignments to be submitted on time, and if your assignment is late, you will get 50% credit. And that is basically 50% credit after the due date. No work is accepted after the last lecture day. The last lecture day for this course, would be not June 23rd. I mean, it would be June 23rd, excuse me, and not June 27th. So please keep that in mind. Exams are taken online to answer that question. So to further continue, there's a little bit on the grading criteria. Final, midterm, and labs are worth these percentages. Final is worth 40%, labs are 30, midterm is 30. So, and you're given about 8 assignments in this course. And this is how I assign the grades. This is basically provided to me from the this guidance is provided from Dianza's handbook or from Dianza administration. So we just all follow the same grading system for grade assignments. If you do end up taking the class for credit, no credit, or pass, no pass, you can simply let admissions know. I still submit a letter grade, but they determine pass or no pass based on this criteria. Okay, so any other questions on the course? What content is being covered? Any questions on that? Submitting lab 1. We'll talk more about code submissions when we get to that point. I'll set up the discussion board, which is using Piazza. And then the last thing, which is in fact, the most important one to there's one account that you need to create. You have to create a UNIX account. And so the instructions for creating the UNIX account are on my website under the content area. And we can actually work on this next week when we'll need this information. So you can go under accounts area and you've got information on creating the UNIX account, which is both for if you're trying to work with Windows system or Mac, there are instructions here. And I'll actually do a show and tell on this by next Tuesday. We will need this for assignment 2, not for assignment 1. So please, yes, start the work, but don't feel rushed. And if you need one-on-one assistance for this part, it's perfectly fine, because I don't expect you all to be a Unix guru to work with this course. And so I can provide some assistance for a few minutes to get you all started. I will be creating an Oracle account for you all. And again, once my class list settles, I will create that by this Friday and then email you the details. So then next Tuesday, I'll show you how to use that account as well. I do suggest, we have talked about UNIX account and Oracle account. And I do recommend creating an account on this website, which is the Oracle Technology Network. This is an online encyclopedia for the Oracle technologies. So this is just a web form. You can use your email, and the reason I request you to create this is so you can download the SQL reference and other material on need basis in the future. So if you become a professional with Oracle database, this might be the one that website that you'll go and refer to quite frequently, and that will be the case in this course as well. So creating that account will be a great idea. Again, no rush on the accounts. Just take your time, and we have about a week. And please do reach out as and when you may need assistance with it. A little bit about myself. I've been working with in software engineering arena since 1993. I was working in the data server group at Oracle in the first couple of jobs I had as a software engineer. So I've spent time working on database partitioning and other features in Oracle 8 and Oracle 9. From a software engineering perspective, I focus on software design mostly with Java and Android development. And I've been teaching at De Anza since 1997 as well. So I'm hopeful that I will be able to provide you with a great learning experience. And if there's anything that you feel will make this course a better experience for you all for learning, just send me an email with your suggestions, and I will be glad to apply and assist to make this better. So with that, we can start talking about today's first technical topic, which is Intro to Databases. I'll give you all a few seconds to just ask if there are any questions I should address before I continue with the topic of Introduction to Databases. Our first topic in this course is learning the basic features of a database. By the way, when I'm posting video lectures, I'll be posting these links that are highlighted. Are you guys okay with me leaving these older links for your reference, or from last quarter, or shall I remove these? This is where the video lectures will go. Do you want me to leave them alone? Okay, great. So the dates are there, and that way you can have a backup reference as well. And in case some of you want to work a little ahead, you can still use the video lectures from last quarter. Okay. Okay. So now we talk about database basics. So when I talk about databases, the idea is that we talk about basic features and we talk about also the database architecture at a high level. I'm going to focus just on the theory of databases, and then the database architecture. I'm going to introduce you to some documentation, and just a little warning that the documentation can be a little, it's a little dense from technical perspective. And so what I want to do is just say that, okay, glance the documentation, but don't spend too much time trying to understand everything in it. Because what we're going to do is, once you go through the 5 lab assignments, then I'm going to go back and review that in a little bit more detail. So then it'll make a lot more sense than, say, the first day of class. If you try and understand it on the first day, you'll most likely want to drop the class because you'll be like, this is too technical and getting too dense. So, but I just throw it out there just for your reference, and then we'll come back and review it later. So we're going to today focus on just the theory of the database, the features of the database, and we start with the basic definition. Like, what is a database? So it's like a storage structure that you can use to add a record, delete, update, or retrieve information from. Anything can act as a database. I mean, if you take a piece of paper and you write information on it, when you can add or remove or erase information. So a piece of paper can essentially become a database. But here, of course, we are talking about languages and tools that we are going to use to work with electronic environments and the database. So then we can talk about text files and Excel or Oracle database or Microsoft Access database. Now, size matters. For the database size, for any database, the size becomes material. So you can have a database for your phone numbers in your cell phone. So that's a database size that we talk about. Then we can have a database for storing grades of all students taking classes at De Anza. And then we can talk about a database size of storing grades for all students taking class in all colleges in US. I mean, just think of the scale, right? So I'm just trying to give you guys an idea of the size. Storing videos on YouTube. And what about storing all images on Facebook? How many users are there on Facebook? Anyone knows? Let's Google that, right? Number of Facebook users. So as of April 2016, Facebook has 1.86 billion users. Think about that. What is the world population? 7 billion. 30% of world's population is on Facebook. I mean, China's population is 1.3 billion. India's population is 1.25 billion. And Facebook will be bigger than India and China combined soon. So Facebook users in 2017, right? I mean, we are at 2 billion users as of Feb. Give them a couple of years more, Facebook will be bigger than India and China's population combined. Now, let's take that information and talk about storing images on Facebook. Okay? So size matters. So you have to think about your bits and bytes. So you have to get to know your bits and bytes. So we're going to focus a little bit on, you guys know about kilobyte, of course. You know about megabyte. You all know about gigabyte because the hard drives you buy for your computers are now in gigabytes. Even your cell phones has unit of measurement that is used in gigabytes for memory. If you buy hard drives, that's terabytes. Then we get to petabyte, exabytes, zettabyte, and yottabyte, right? How many of you already know about zetta and yotta? And has anybody heard about pronto, right? So, these units of measurement we have to focus and learn on, right? So when we look through, I'm actually going to throw this link for you all to focus on so you guys can, so I'll just add a little note here. Please review your bits and bytes, right? Please get to know those. So a petabyte is 1,000 terabytes. And we can also say database size for Facebook. So Facebook has revealed these statistics, and you try and figure out which storage unit which storage unit they are going to use. They have to talk in terms of petabytes today. So review some of this. It's actually fun to know this. So when we start talking about databases and database sizes, we can talk about relational systems all day long, but relational systems today are shrinking, from a usage perspective in the industry. There's a term called big data that has emerged. And big data refers to anything that is beyond petabytes, exabytes. There are some newer units of measurements that will emerge because the amount of data that is being generated is basically it's going to go beyond yottabytes. As we work with as we work with the data growth in the different industries that we are working with. So databases, folks, are used in all the 23 industries where computing is pervasive. And examples are aviation or aerospace, biotechnology, healthcare. So when I start talking about databases and I talk about usage in all of these industries, and there are a lot of companies that are coming up with newer technologies to deal with different types of storage today. So one participant in the room is saying that we have to use 105 terabytes for each half hour. So you can just imagine the velocity at which Facebook is generating data for its users based on the storage. And another thing today is also that when you all take a picture, you're spending, the size of one image that you're posting on Facebook is pretty large. So, and it's amazing that the Facebook structure handles it all, right? So the part of this course is to at least help you scratch the surface to begin, so you can begin to have an understanding of how these structures work, and you know, what are the underlying technologies and how those work. So our focus in this course is on relational systems. So let's talk about different types of databases. While all of that was hopefully very exciting, there is a there is a technical piece to this puzzle that has to be made clear. So obviously there are different languages and tools that are used. There are some that are third generation and fourth generation. This refers to the type of programming languages. Then there are predefined programs. So you can have tools that you can use for doing queries, doing reporting, or developing new products on the database. So back in the Stone Age, if I may, we would use flat files. So like when I'm creating this little text file, this is basically a storage structure. And I can make this text file formatted, or I can use a formatted file, which means that it uses each row follows the same format. Like, when you create a comma separated file, CSV files, I'm sure you are familiar with already. And then we have unformatted file, which is somewhat random, like the notes taken in this file, right? So unformatted file. Then as we progress through the different storage structures, we have hierarchical database systems. So what we started doing with the hierarchical databases is creating text files that are linked using programs. And I'll give you an example of this in a little bit. We also have network databases. So basically taking these text files and putting them on different computer systems, so they're available online. Then we have relational systems where we actually create, we don't use text files, but we end up creating a database and tables, and then link the tables. So sorry about that. In the relational system, we create tables and link. We create tables and link them inside a database. One important thing that is going to come up in the next slide is that if we work with text files, what are the issues with working with text files? And how is that problem solved with database? And then of course we get into object-oriented databases where we apply the principles of object-oriented design. So if some of you end up taking like a course in Java or C++, you will most likely end up learning object-oriented programming. So we take that object-oriented design principles and we apply them to databases for creating object-oriented databases. Then beyond this list of database systems that we talk about, there is also today, there are also systems today that are using, they're not using SQL. So we call those NoSQL databases, NoSQL DBs, providing large-scale storage, basically in order of peta, exa, or zettabytes. So if you think about these sizes, that's where we are talking about big data. And so we are using thousands of computers. We're using thousands of computers and that are on a network using and both, they can either be structured or unstructured. So large-scale storage systems with big data are mostly without SQL. Those are NoSQL structures, databases, and that is an accurate statement. So because relational systems can only handle or provide the relational systems can only go up to the order of maybe terabytes or petabytes. So now let's go back, and I know the conversation of big data is the most current thing and a happening thing, if you will. But we have to go back and look at how the nuts and bolts of storage systems of databases work. And so then we can learn the elements of relational systems before we go to these unstructured NoSQL databases. So what happens when you work with text files? So here is a slide that actually helps you understand it in a nutshell. So please look at this carefully, and very quickly you'll know in like 2 minutes or less what the issues are. Let's say we have a customer file with customer name and address. And we also have an order file with order number, product that is ordered, and quantity. And then we have a product file with the product ID, the name of the product, the price, and the description. So you can quickly see customer, order, and product each saves information about the element that is referred there. Like, we have customer information in customer file, we have order information in order file, and product information in product file. We also take the time to generate an ID, a unique number for the customer, for the order, or for the product. So when we refer to, like when we go to McDonald's to order a product, for efficiency, they often say, what number do you want? I mean, if you have to explain what you want to order, it takes a lot of time. So instead what we do is we say, I would like number 1 with large fries. Sometimes I still go to McDonald's and order, so don't judge me on that, okay, please? But there is that efficiency, right, that the order processing gets by using a number. So customer number 1 is then referred to in the order table. And if I'm ordering a specific product, I have a product ID that is referred to in the orders table. So you see, we're starting to create these links between files. But the links actually don't exist in the flat files. Those are created inside these programs. Does everyone understand the idea of a link between files? What we are trying to say is that when we create a product, we create a product ID, and then I use that ID in the orders table to refer to that specific product ID. And so maybe this will become a little more clear if I actually throw some data, right? So why don't we do that? So right here in Excel, I'm going to go ahead and create, so we have those 3 tables that you can see. So I have my customer table and I have ID, name and address. And then I have my order table. Actually, let's put the product table first. So product will have ID, name, price and description. So let's say the customer is Bob, customer ID 1, Bob, and some address, 123 anywhere. Not writing that in detail for sake of time. And product ID is 1 and name is Big Mac. And price is $2.99 and description is healthy fast food. Okay, so now we are starting to set up our database, if you will. And I think if I left align it will be a lot easier, or maybe central align it. So this is my header, and that's my data. So there's another customer, Sally, at another address, and we have another product. So we have nuggets, and prices, say $1, and it's even healthier food. So now we are going to go place some orders, right? So we are going to put up an order table, and we're going to say we have our customer ID. We're going to have the order ID, product ID, and quantity. So, and I'm sure you're still observing this wonderful spreadsheet that we are creating to capture orders. So customer ID is 1, right? So that 1 refers to Bob. And so order ID is 1, and I'm going to order product 1. And since I'm feeling good today, I'm going to put the quantity 2. Okay. So this is what I mean by links. So if I can say customer ID 1, and folks, please forgive me, I'm actually colorblind, so I'm going to do my best to color code these the same, so you guys can begin to see the links that we are creating. So a little visual always helps, right? So those are links that we have created, where customer 1 is buying. Yes, I can totally do that. Oh, sorry, that's too large. Does that work? Okay, great. So now you can see things are color coded, Now if customer 1 on the same order wants to order nuggets because it's even healthier, right? So what will the order total be for order ID 1? Can somebody do a quick math and tell me? What's my order total? $9. Okay, very nice. So is the idea of links understood by virtue of this picture? Everyone, I request a response. Should the second customer ID be 2? No, it's me, Bob, ordering a Big Mac, 2 Big Macs, and Bob ordering 5 nuggets. It's supposed to be a healthy day today. So, okay, all right. Now I could add another, Sally could say, all right, I will order one of each. So then Sally has order number 2 and she's getting a total of how much, what total is she going to pay based on this picture? $3, right? Somebody already computed that for me. Thank you very much. So these links are maintained in programs, right? But the problem is because the links are not in the files, I can actually go and change customer ID Bob to, for Bob to 3. And now this link is broken, you see. Both of these were supposed to be 1. So what we are saying is when I change the customer ID to 3 in a text file and I don't update the order, then the link is broken. And that's what is the problem between text files. You can end up with data inconsistency when the structure of the text file changes. What if I go back and rename the ID to, I don't know, customer ID? So when the ID names are different and the linkage is then not there, then that becomes a problem. So that's where the relational database comes in. So we basically say, well, rather than create these separate text files, why don't you all create tables? Like these, you have these Excel spreadsheets. Each spreadsheet is like a table. And then let's create logical links between the tables. So that's what happens here. We go ahead and create the 3 tables. We end up creating logical links, and all of these are stored inside one database. And this one database can have multiple data files, like file 1 and file 2. But it's not that we are saying customer table is only in file 1. Customer table can have information in file 1 and file 2. So, and depending on the rows, we just store the rows anywhere we want. So this way we can, we're not really associating the database to files. We are associating the data to a logical structure called a table that has rows and columns like in Excel. And then we start creating these links between the tables. So first of all, I'm not required to use the same column name, but I have 3 columns: customer ID, name, and address. And when I want to refer to a specific customer, I make a link between the 2 tables. So I take the customer ID and I link that to the customer. I take the customer ID in customer table and I link it to the customer ID in the order table. So now with those links present, I have data consistency. So there are some important notes to be taken here. So when links are present in relational tables, we get data consistency. So if order table has an order for a customer and I try to delete the customer from the customer table, database will throw an error. It will say you can't do that because there are orders for a given customer, right? Second thing, if I try to insert an order for a customer ID in order table and the customer does not exist in customer table, then database will throw an error. See, in text files it doesn't matter because there are no links, right? But in a database, so basically it prevents me from placing orders for customers that do not exist in the database. Unless I have a cash customer, then that's fine. But if I am dealing with some corporate accounting and I start creating orders for customers that don't exist, then that's of course a very negative thing. Same thing for product ID. Like if I want to cannot place orders for products that do not exist in product table. And last one, cannot delete product ID or customer product ID in product table that does not have cannot delete product ID in product table that does not have that has an order, that has an associated order in order table. So if you review this carefully, you're going to find that this is the basis, this is how the relational database helps us. And so we can basically say in a nutshell that RDBMS enables referential integrity because you can cross-check the tables you see with the links. So cross-checking tables with links is the basis of referential integrity. And that's what we are talking about with relational databases. So now once we set these up, or if you have to set these up, the next question comes up is how to set up referential integrity. Before I proceed to this topic, I just want to make sure that if you guys have any questions that I can potentially help address. Everyone doing okay? So referential integrity refers to ensuring that links are first set up between tables, and then when the links are created, then you cannot do any of these things. And RDBMS stands for Relational Database Management System. All right. So then the next question is, how do you set up referential integrity? And that's where we introduce two terms, primary key and foreign key. So primary key is a unique ID. It's a unique value, typically a number, but can be any data type, to identify a row in a table. So like your social security number can be a primary key, or your driver's license can be a primary key, because we know they will hopefully never issue a duplicate license number to another person in the same state, or a duplicate social security number, because that's how we pay our taxes, and our credit history and all of that is identified with our social security number. So it's a very private thing. So it has to be unique, and that's what a primary key is. Now, foreign key is a column that is created to refer to a primary key. Just like I was doing this in my customer and product and order tables, customer ID is the primary key. So let me reset all these colors so I can all these are primary keys. Yep. So primary keys. Nope, that's not it. Here, yeah, product ID will be a primary key, and order ID will be a primary key. If I make order ID a primary key, then I cannot save two rows, So the way I'll end up creating a primary key here is I'll include these three things together in a primary key. So what that means is this entire row will act as a primary key. So that basically means a customer on one order cannot order the same product twice. So if I wanted to say, one Big Mac and another Big Mac, I should just state the quantity 2 and be done with it. And foreign key that I refer to would be like customer ID referring to this customer. So I would take this column and impose another color. So I cannot do duplicate colors, but customer ID is a foreign key to customer ID in the customer table. And same thing for this guy. Product ID is a foreign key to the product ID in the product table. Okay. So the idea of primary key and foreign key is very simple, and this is what creates the logical relationship, if you will, in tables or in a relational database. Very important. So So then what's next? You've got some simple operations like database that introduces you to the database manipulation language. So what is a foreign key? Foreign key basically refers to a primary key. So when I say customer ID 1, right? If I say customer ID is 1, that means it refers to this entire row. And that's a link. If I say Big Mac in product ID, let's use a different color for that. Then that means I'm referring to the healthy fast food. Okay? Foreign key. It's creating these links, so now in my order table I don't have to say Big Mac. I just can say product ID 1. It's that same thing that we do when we go to we go through like fast ordering through like you're in a queue in McDonald's and you're ordering the product and you say I want number 1. You're referring to a foreign key sort of there. So then to work with databases, we have database manipulation language. So we can select, insert, update, and delete data. And some of these statements that follow essentially show you how to do that. So how to select data from a database. And there's a little bit of a syntax, or I'd actually demonstrate this to you all next Tuesday. But in fact, why don't we do it right now? So I'm going to use a tool called Putty to access the database. And I know you guys can't see that font size, so let me increase that font. Can you all see that? So I'm going to log in. And then I'll log into okay, great, it likes me. So I'm just going to go through the select statement. So I have an employee table that has these 8 columns, as you can see, right? So obviously you're not going to want to remember all this. So what I'll do is I'll put this in your text file. And I'll have this on the side here. So what I'm going to do is start writing some SQL statements, and generally when I'm writing my code, I like to write it in the text file. Sorry, excuse me for that issue with Windows that just auto expands. So I'm going to say I want to select star from EMP. This is a select statement. So we have, when we say select star, that means I want to select all these 8 columns and from the employee table. So from clause is generally to refer to the tables that I'm going to, and the select is to select specific columns. So if I want to bring up everything, I can just take this one line, and in Putty, when I log in, I'm going to right click. And of course, folks, I'll go through logging into the database and setting up the accounts and all of that good stuff properly and carefully with you all next time, okay? So that way you guys will be able to access like I am. But my goal right now is just to briefly show you, how some of these statements work live so you guys can, see the code in play. Now, when I take that code and I right click and I paste it, then it shows up here, and if I hit enter, it says from EMP is an unknown command. So something went wrong there. So I'm going to go back and copy it again. So I'm hitting Control C, and then I right click on the mouse in Putty window, and you can see the results. I've got employee ID 7839. King is the president of the company, was hired in 1981, has a salary of 5,000. So now if I want to only bring in, like a smaller data set, like I would like the employee number, the employee name, and the salary, right? That is like the most important thing I want to know about everybody in the company. So then I can say, select those 3 columns and from the employee table, and you can see how much money everybody makes. But now I want to sort this data, right? I want to look at all the employee names in descending order. So then I can say order by. So order by e-name descending. So that's going to sort the data in the descending order for me. So you see the last name Ward appears first and Adam appears. Ward appears first and Adam appears last. It's in descending order. If I want to see who's making the most money, right, that's always interesting to look at other people's salaries and say, oh, you make so much money, right? So we can say order by salary descending. Of course, I'm just joking about salary, but it's just. So King makes most and Smith makes the least. So, right? So a little bit of SQL that you can see in play here. So this is the starting point of the select statement. If I want to bring in some only unique values, so let's see what things are duplicate. So as you can see, like 2 individuals make the same salary, right? And there are 14 rows total. So if I said something like this, like select distinct sal from EMP, and then I'll just do the same, like order by sal. So what that is going to do is it's going to get rid of all the duplicate rows. So I get 12 rows instead of the 14. Why? Because there are 2 rows that were duplicate, 3000 and 1250. So 1250 only appears once and 3000 only appears once. So that's the usage of distinct. So we also have the ability to insert a new record. So we say insert into table and values. And that kind of looks like this. We'll talk more about this in detail. You can update existing data. So if you want to change my salary from 5,000 to 15, I'll take that any day using an update statement. Well, in fact, if you give me the database access, then I can take care of it myself using the update statement. It would be illegal and I'll probably not be employed for very long, but that's how the update statement works, at least. We can say update table, set column to a value with a where condition. Something like this. Update employee, set salary to 3000, where name equals the name of the person. Of course, this kind of an update statement is only allowed by HR and they go through a very strict process where the database is private, and the change in the salary is approved through a process. So because this is the company's bottom line. So being compliant with the with those processes is very important. So nobody can just go in willy-nilly and change. So, deleting the data. So deleting a row or deleting the entire table. So we can say delete from table with a where condition, something like this. So what will this statement do in your opinion? Anybody give an idea? It will, yeah, it will delete all employees in the table that have a salary of 1,000. Yeah, that's correct. Good job, guys. It will delete all employees with salary of $1,000. So the next thing we get into is the Oracle architecture. So what I would like to request you is you can glance through these slides, and also on the website I have the slides on Oracle architecture. And I'd say that you can just glance through these, but try not to understand everything because we're going to go through it in the end of the course. And that way, because you would have gone through learning the language and you would have worked with a few tables, understanding this will become a lot easier after you're done with the 7 or 8 assignments you have in the course. So your first assignment is to answer these 4 questions. So you'll have to do a little bit of hunting. Like, I think you can work with, we went over primary and foreign key, so that should be easy after a review. Data dictionary. You'll have to hunt a little bit on this. I've talked about the idea of a table already. So that question is answered about like half of it. But the other half is the purpose of the data dictionary. So data dictionary should be data dictionary is a group of tables that are used by the database to keep all the information about the database, right? So significance of a column and a row. We should be able to explain that. And what is referential integrity, which I also talked about. What does it mean to have a comma when a comment starts with a comma? So in the documentation, so the documentation is a little has a little formatting when it's set up in the, especially the Oracle documentation, right? When we say set column equals value and we start with a bracket, that just indicates, that's not part of the syntax, but that simply indicates that those values are optional. Okay, so and when we have a comma operator, that basically means I can set more than one column. So like when I have an update statement and I say set salary equal to 3,000, next thing I can say is a comma and add another column equal to value. So that's how this is structured, that this part is optional. And if you do end up using it, please put a comma between different column and value name pairs. Okay. And like this, it also means that the where clause is optional in the end. Does that make sense? Or does it answer the question? I mean, is what I meant, sorry. I'm sure it does make sense. And if there's a follow-up question on that, please do let me know. So what you have to do is go through this assignment, finish the 4 questions, and email them to my favorite email address, which is cislabs05@gmail.com. Okay. And excellent question. When are the assignments due? So you can check with my digital assistant here anytime. It's always here. And these are the due dates. It's April 20th. So, okay. So this is all I have for today. The due date time is midnight of the due date. If you're 5, 10, few minutes late, it's not a big deal. But please don't be like a whole day late, because then you get 50% credit. All right, folks, have a wonderful Tuesday, and I'll see you all next Tuesday, same time, same place. You're all welcome, and take care.